For today's lesson, we will be discussing about the tangent and normal lines to a curve. So we will discuss what is a tangent line and also what is the normal line and how are we going to use the tangent line in order for us to identify the rate of change of a given function. So first, let's define what is instantaneous velocity. Instantaneous velocity, it is the velocity of an object under motion at a specific point of time. So let's say you throw a ball and you want to identify what's the velocity of that ball at a specific second. For example, 2 seconds. So we call it as instantaneous velocity. So we solve for instantaneous velocity using the slopes of tangent lines. So in order for us to identify the rate of change in a function, we also use the slopes of our tangent lines. Now let's recall first what is a tangent line. So a tangent line, it is a line that intersects a given curve at exactly one point. So let's say this is your curve, or this is the function, this one right here, and then this line, this one is what we call as a tangent line, and they intersect, or it intersect the curve at exactly one point, and this point is what we call as the point of tangency. So if we want to identify the instantaneous rate of change of our curve, or this curve right here, given a specific point, then we can use the slope of our tangent line. So again, this is what we call as our tangent line. So aside from the tangent line, we also have what we call as the normal line. So it is a line that is perpendicular to a line tangent to a given curve. It passes through the point of tangency. So this one right here, this is our normal line, and as you can see, it is perpendicular with our tangent line. So it still passes the same point, the point of tangency. Now since the two are perpendicular, one thing that we have to remember is that their slopes are negative reciprocal of one another. So again, so the slopes of our tangent and normal line, they are negative reciprocal of one another since they are perpendicular. So now what we will do is we will try to use the slopes of our tangent line in order for us to identify the rate of change in our function. So we want to identify how the value of the function changes along the curve. So in order to do that, so we will be applying the derivatives as well. So for example, we have this function x squared minus 5x plus 3, and we have the point 2, negative 3. What is the instantaneous rate of change of f at 2, negative 3? So this point 2, negative 3 is within our function. So let's say we draw this curve right here. Let's say this is the function. And then we have this point here, the point 2, 3. So we want to identify what's the rate of change of our function given at this point right here. So in order to do that, what we will do is we will apply the slope, or we will use the slope of our tangent line. So this one, let's say this is a tangent line. So the slope of our tangent line will also give us, or it is just the same as with our rate of change. Okay, so in order to do that, first the thing that we have to do is to get the derivative of our function. So this is our function. Let's get a derivative of that. Since there are 3 terms, they are separated by addition and subtraction, so we can just get the derivative of each of them. So derivative of 5x plus the derivative of our 3. So here we have 2x minus 5. So this one now is the derivative of our function. Now, since we want to identify the rate of change of our function at this given point, so after getting the derivative, well, what we will do next is to evaluate the derivative using the x coordinate in our point, which is 2. So you just have to substitute here. So 2 times 2 minus 5. Therefore, the value that we will get is negative 1. So this is now the rate of change of our function at that specific point to negative 3. And this point, or this value right here, this is also the slope of our tangent line. So we can also say that the slope of our tangent line is -1. So the slope of the tangent line is just the same as the rate of our change of the function. Now, let's say we want to identify the equation of the tangent line to the parabola. So we have the same function and then we have the same point. So if we want to identify the equation of our tangent line, so we have to use the equation, the formula for the equation of a line. Since we already have the slope of our tangent line, so slope of our tangent line is -1. Since as what we know, it is just the same as with the rate of change of our function. And then we also have this point right here, the 2, -3. This is the point of tangency. That means it is part of our function f of x and also part of the tangent line. Since we have here slope and point, so we will be using the point slope form. Point slope form. So what is the point slope form of equation? So that is y minus y sub 1 equals m times x minus x sub 1. So we will be using this formula to identify now the equation of our tangent line. So this is our x sub 1, this is our y sub 1, this is the tangent or the slope of our tangent. So we just have to substitute here y minus -3 equals then the slope times x minus 2. Then we have to simplify this, y plus 3. Then distribute -1, so negative x plus 2. And then we just have to arrange this, so x plus y equals 2 minus 3. So therefore, we have x plus y equals -1. So this equation now is the equation of our tangent line. So we're able to identify the equation of a tangent line because we already have the slope. So in order for us to get the slope, we identified first the derivative and then evaluate it by the x-coordinate of our point. Now, we have to solve for the equation of the normal line. So since the normal line is perpendicular to our tangent line and we are just talking of one function here, we know that the tangent line and normal line are perpendicular with one another. So if the slope of our tangent line is -1, therefore we can say that the slope of our normal line is the negative reciprocal of our tangent line. So if our tangent line is -1, so its negative reciprocal should be equal to +1. So this is now the slope that we will use for our normal line, since again, the two are perpendicular with one another. And then we will be using the same point since our normal line also passes this point, the point of tangency. So we will apply the same formula, the point slope form. So y minus -3 equals, this time the slope that we will use is 1, and then x minus 2. So this is y plus 3 equals, and then we have x minus 2. And then what we will do is, just have to arrange this. So I will just put y on this side and then the -2 here. So that's 3 plus 2 equals x minus y, so that we can keep our x variable positive. So this is 5 equals x minus y, or our equation of the normal line is x minus y equals 5. And then that's it. We now have the equation of our normal line. Another example. So let's say we have g of x equals x squared plus 3. And we have here x equals 1. So first question is, what is the instantaneous rate of change of g at x equals 1? So again, in getting the rate of change of our function at a particular point, so we have to get first the derivative. So this is our function. So we have the g of x equals square root of x squared plus 3. So we have to get the derivative of this first. So here, we can rewrite this as x squared plus 3 raised to 1/2. So we write the square root or the radical equation into its exponential form, which is this one. And then, since as we can see here, the base is still a function that is differentiable. So we have to use the chain rule here. So we will set that as our u. So this is x squared plus 3. Therefore, this function, we can rewrite this as u raised to 1/2. And then from here, we will be using now the chain rule. So g prime of x is equal to, so in chain rule, we have to get the derivative of the whole function, which is u raised to 1/2, then times the derivative of our inner function. What is our inner function? It's x squared plus 3. There. So u raised to 1/2, just use the power rule. So you will get 1 over 2 square root of u times, and then this one, get the derivative, so you have 2x. Multiply the 2, we will get 2x over 2 square root of u. You can cancel this, therefore, our derivative will be x over square root of u. And then we still have to write or rewrite u into its original form, so that will be x over square root of x squared plus 3. So this is now the derivative of our function. Now, in order for us to get the rate of change at this particular point, so we just have to evaluate it at x equals 1. So this will be g prime of 1 is equal to 1 over, and then square root of 1 squared plus 3. So if you simplify this, you will get 1 over square root of 4, or 1/2. So there. So this is now the rate of change of our function at x equals 1. Now, let's try to find the equation of the tangent line to g at the point where x is equal to 1. So, like what I've mentioned a while ago, the rate of change of our function is just the same as the slope of our tangent line. So, since our rate of change is 1/2, we can say that the slope of our tangent line is 1/2 as well. And then, notice that we only have the value of x, which is 1. We do not have the y coordinate. So what we will do is, in order for us to identify the y coordinate of that point, or the point of tangent c, you just have to substitute 1 to our function. So g of 1 is equal to, then you have square root of 1 squared plus 3. We are doing this so that we can identify what is the corresponding value of y given that x is 1 in this particular function. So simplify this. 1 plus 3 is 4. Square root of 4, you will get 2. So that is the value of y that we will use. And then all you have to do now is to use again our point slope form. So y minus 2 equals, then you have the 1/2 times x minus 1. So what you can do here, y minus 2 is equal to, you can multiply. So we have x minus 1 over 2. And since there's a denominator, you want to remove that. So we will just multiply the whole function by 2. Multiply it both sides. So here we have 2y minus 4 equals, and then this will be cancelled. So you will get x minus 1. Then all you have to do is to rearrange. So negative 4 plus 1 equals x minus 2y. Or if you simplify this, we have x minus 2y equals negative 3. And then that is already now the equation of our tangent line. And for our last example, find an equation of the tangent line and the normal line 2y equals e raised to x over x squared plus 1 at the point where x is equal to 0. Okay, so we have to find the equation of the tangent and the normal line. So before we can identify the equation of the tangent line, we need to have the slope of our tangent line. And as what we know, slope of the tangent line is just the same as with the instantaneous rate. So the process that we did a while ago, so we have to do it again. First is get the derivative of our function. So this is our function. So since, as you can see, e raised to x is divided to x squared plus 1, so we have to use the quotient rule. So this is our high, this is our low. So we will apply the quotient rule here. Low, d high minus high d low all over low squared. And then we just have to get the derivative of this. So x squared plus 1. And then the derivative of e raised to x is just e raised to x minus then e raised to x squared plus 1, its derivative is 2x. And then all over x squared plus 1 squared. So this is now the derivative of our function. If you want to simplify, go ahead. But the next step that we will do is we just have to evaluate this with our value of x. So no need to really simplify this. So after we get the derivative, we have to evaluate this given the value of x, which is 0. So this one, where x is equal to 0. So all you have to do is just to substitute all the x here with 0. So we have 0 squared plus 1 e raised to 0 minus e raised to 0 times 2 times 0 all over 0 squared plus 1 squared. And then, so this is just 1 times 1, e raised to 0 is 1 as well, minus this is 1, and then this is 0. And then for our denominator, 1 squared, so you have 1. So if you simplify this, you just have 1 as our value. So this one right here, this is now the slope of our tangent line. Okay, so that is now the slope of our tangent line. Now let's solve for the equation of our tangent line and also our normal line. So the slope of our tangent line is equal to 1. Now the point here is, or the x value is just 0. So we do not have the y value. But what we will do is we just have to substitute 0 to this function so that we can identify the corresponding y value. So y is equal to, so e raised to 0 over 0 squared plus 1. So this is just 1 over 1 or equal to 1. So the corresponding y value of that point to our function is 1. And then let's substitute now to our formula. So y minus 1 equals 1 times x minus 0. So just simplify this. Y minus 1 equals, so 1, and then this is just x minus 0 or x times 1. So you just have x here. So you move y on the other side. So you have negative 1 equals x minus y. And then arrange x minus y equals negative 1. So this is now our equation for our tangent line. Now for our normal line, since the slope of our tangent line is 1, so we just have to get the negative reciprocal of our tangent, or the slope of our tangent. And that will be equal to negative 1. And then we will be using the same point, 0, 1. So 1 minus 1, y minus 1 equals negative 1 times x minus 0. So here you have y minus 1 equals x minus 0 is x times negative 1, negative x. And then move x to the other side, so x plus y, and then move negative 1 on the other side. So you have positive 1. So therefore, this is now the equation of our normal line. So again, that is how we identify the rate of change of our function as well as the equation of our tangent line and normal line. So first, if you were asked to identify the rate of change, instantaneous rate of change of your function at a given point, so you just have to get the derivative of your function with respect to x. After that, you evaluate the derivative using the point or the x coordinate of the point. Now, the value that you will get there, that is the rate of change of your function, and at the same time, it also represents the slope of our tangent line. Now, once you already have the slope of your tangent line, you can now write the equation of the tangent line using the point slope form. And if you want to write the equation of your normal line, you just have to get first the negative reciprocal of the slope of the tangent line, and then use again the point slope form. If in case there is no value of y in the given point, you just have to solve for it by substituting the x value to the equation or to the function given so that you can identify the corresponding y value. And then that's it. You can now write the equation of the tangent line and the normal line. So that's it for today. I hope you learned something about the tangent line and also the normal line, and see you next time.